Peninsular Malaysia needed extra power. ABB manufactured all units, and Jumbo Shipping, together with Container National, transported the heavy equipment for the 3 power station extensions in Paka, Pasagudan and Connaught Bridge. All 3 job sites are quite far apart. Paka power station is on the northeast coast, Pasagudan is down south, and Connaught Bridge is west of Kuala Lumpur. Paka and Connaught Bridge power stations were particularly difficult to be reached with heavy equipment. At Jumbo's operational office in Rotterdam, detailed plans were worked out based on the surveys carried out earlier. Since these bridges near Paka could not be crossed with a gas turbine of 182 tons, it was decided to use a flat-top barge from Kemaman supply base and tow it along the coast to the Paka river entrance. In February 1991, the first 2 generators and 1 gas turbine were loaded in Rotterdam on board Jumbo's heavy lift vessel Fairlane. It was freezing cold and quite different from the tropical temperatures we were used to during our surveys in Paka and Connaught Bridge. The gas turbines and generators were assembled by ABB's plant at Mannheim in West Germany and arrived by river barge in Rotterdam. Immediately after loading in Rotterdam, Jumbo's project manager took the next flight to Singapore and continued with the necessary preparations. Steel supports and ro-ro rams were manufactured in record time and placed on board the barge. The Malaysian transport contractors were instructed, and approximately 1 month after departure from Rotterdam, motor vessel Fairlane arrived in Kemaman supply base, the nearest harbour approximately 40 kilometers south of Paka power station. The shallow draft barge is moved in between ship and quay, so that both generators can be placed on the steel support structure. Slowly, the first 160 tons generator is lifted from the bottom of the hold. The Fairlane is equipped with 2 300-ton derricks and has ample lifting capacity to handle these loads. To make sure that a generator arrives on site facing correctly, it had to be turned, which was an easy task with this single hook lift. The heavy lifts are placed on steel supports, enabling the hydraulic platform trailer to roll underneath them upon arrival at the Paka ro-ro jetty and to load each generator or gas turbine by means of the hydraulic lifting system of the trailer. Finally, the last heavy item, the 182 tons gas turbine, is lifted by the aft derrick and placed on deck of the barge. The yellow pontoon at starboard side of the Fairlane is a so-called stabilizer and increases ship stability during loading and unloading operations. End March 1991, 2 160-ton generators and 1 182-ton gas turbine were placed on the deck supports and lashed and secured for towage. A deep-sea tug from the port of Kemaman towed the barge 40 kilometers along the coast to the Paka River. The shallow draft tug followed the convoy and took over at arrival near the Paka River entrance. Local fishing boats assisted us in navigating the barge along the many sandbanks in the river. The sea was calm this time. The monsoon period had come to an end, and thereby also the heavy swell which we experienced earlier at this location. Nevertheless, it still is difficult to navigate this 180 feet barge past the many sandbanks at starboard side and rocks at port side during the outgoing tide. Due to depth restrictions in the Paka River, we can only enter the river at high tide. Floating channel markings were placed to indicate the deepest part of the river. Gradually the barge proceeded to the temporary ro-ro jetty, which was constructed approximately 1 mile upstream near the bridge. We still had to act quickly as the current had changed direction and threatened to push the barge against a nearby bridge. With an Indonesian tug captain who didn't speak English, it was not always easy to communicate. Finally, the barge was moored safely at the jetty and ballasted aground. A mobile crane lifted the 15 tons diffuser from the barge and preparations were made to roll off both generators and gas turbine. The jetty was constructed at the same height as the barge. In this way, no ro-ro ramps were required, and we only used some steel plates to cover the 20 centimeters gap between barge and jetty. As the barge had been pumped aground, no ballasting was required. Both 10-axle line Commento trailers are all set to roll off. First, the one at starboard, directly followed by the port side unit. The slight height difference between quay and barge deck is easily compensated by the trailer's hydraulic suspension system. Directly after both generators were offloaded at the job site, one trailer went back to load the 182 tons gas turbine and transport it over the 8 kilometers long road to the Paka power station. With 10 axle lines of 8 tires each, the tire load does not exceed 2.7 tons per tire, which is not more than a normal dump truck. The side road had been leveled and compacted, and both heavy-duty tractors pulled the gas turbine to its final destination, the machine hall. Paka power station received 2 identical units, each consisting of a 160 tons generator, a 182 tons gas turbine and a 120 tons transformer using this method. The 2 Pasargudang units were identical as well and could be transported from the nearby seaport directly by road to site over approximately 6 kilometers. The most difficult job site was Connaught Bridge near Kuala Lumpur. ABB had sold 4 units, each consisting of a 320 tons gas turbine, a 236 tons generator and a transformer of 140 tons. As the job site was situated along the Klang River at the left bank, we had to cross the river coming from the nearby seaport Port Klang. The main obstacle in the 22-kilometer long route was this 9-span concrete bridge. Also, the remaining part of the route was difficult and involved temporary removal of traffic islands, pedestrian bridges and electrical wires. So we looked at an alternative. As a Dutchman raised in a country which is partly below sea level, we decided to survey the Klang River. Depths appeared to be okay. We had to pass underneath 5 bridges, of which this one was the most critical. With a clearance of approximately 6 meters at low water and a height of 5 meters 33 for the tallest piece, the gas turbine, it meant, at least in theory, that it could be done under certain conditions. Another problem was, how do we get ashore? There was no ro-ro jetty or landing pier. Evaluating all possibilities, we concluded that transport via the river was the most economical solution, even though we had to build our own inner harbor, ro-ro jetty and access road to the job site. In July 1991, the construction of the inner harbor and ro-ro jetty was subcontracted to a local contractor. Specifications and design of this jetty were all prepared in-house by Jumbo engineers and executed in close cooperation with its local partner Container National. In the meantime, Jumbo's heavy lift vessel Mirabella was on her way from Rotterdam to Port Klang with the first generator and 2 diffusers. The barge, which we previously used for the Paka power station, was mobilized from the east coast to Port Klang and moored alongside the Mirabella upon arrival. Both diffusers were placed at the bow of the barge. To get the deck supports on the barge under reach of the forward derrick, we had to turn the barge. Under expert supervision, the generator was slowly lifted from the lower hold. During loading and unloading operations of difficult and heavy lifts, the ship's captains are always assisted by cargo superintendents from Jumbo's operational headquarters in Rotterdam. Especially for projects which involves on-carriage to the job site, Jumbo specialists prepare all details well ahead of time before ship's arrival. Again, a heavy lift ship of the so-called C-class is used. The 300 tons derrick easily lifts the 236 tons generator and places her on both deck supports of the barge. Only at low water tide we can pass the 5 bridges across the Klang River. The first 2 bridges are approximately 2 hours towing away from the lowest bridge near Klang town. Let's try to pass under the first bridges as early as possible. Timing is very critical. If we are too early, we have to wait for the outgoing tide. Too late means waiting for the next low water. The first 2 bridges are passed 9 o'clock in the morning, just 2 hours before low water. Hopefully we can get to the next bridge before low tide at 11 o'clock. So full steam ahead, and let's try to get underneath the remaining 3 bridges during the same low tide. After 3 hours pulling at full power, we realize that we can't make it this tide, so we decide to look for some strong trees and moor the barge along the riverbank and wait for the next day. Early next morning, we first check the height of the lowest bridge above water level. Still not enough clearance. We decide to move closer to the bridge and wait for the right moment. At the same time, the barge ballast tanks are filled with water to lower the barge deck as much as possible. Slowly we move forward, and with a freeboard of only 2 centimeters, the stern of the barge, we move underneath the lowest bridge. With 8 centimeter clearance, we clearly showed it could be done just as we had planned months before. When the last bridge was passed successfully, all ballast water was pumped out of the tanks so that the barge could be maneuvered into the inner harbour at high tide. With a mobile crane, both diffusers were unloaded and transported to site. The double-wide 8-axle line platform trailer rolled on board via the ro-ro ramps, and the generator was loaded by means of the trailer's hydraulic suspension system. As the ground conditions were very poor, we decided to use a double-wide configuration, thereby decreasing the average ground pressure on the side roads. The transport combination, with a gross vehicle weight of 330 metric tons, was pulled by a Connaught heavy-duty tractor assisted by a tractor mass. Both tractors just proved to be sufficient to pull the combination against the 6% gradient of the ro-ro ramps. The hydraulic axle compensation system distributes the entire load evenly over the road surface. Now comes the last part of a long journey, the transportation from the jetty to the machine hall. Both diffusers, only 23 tons in weight, were transported on a normal low loader. A few weeks later, the next shipment arrived in Port Klang on board of motor vessel Stella Prima. Due to heavy rains, all berths were occupied and we had to discharge all cargo at anchorage. The general cargo was unloaded in the evening of the vessel's arrival, and preparations were made to lift the 320 tons gas turbine the next morning. The Stella Prima is equipped with two 250 tons mast cranes, and with this gear she's ideally equipped to handle general cargo as well as heavy lifts up to 500 tons. The gas turbine is lifted out of the 12-meter deep hold by the two mast cranes working in tandem. During slewing over starboard side, the ship's heel is compensated by ballasting the wing tanks at port side. The barge was turned around so that the gas turbine could be landed on the steel support beams at the stern of the barge. Loaded with a 40 tons combustion chamber and a 320 tons gas turbine, we towed the barge away to the anchorage near Port Klang. This time we were too early and couldn't move underneath the first two bridges, so we had to wait for 2 days. Early morning, the 18th of November, we ballasted the barge down as much as possible and moved towards the first bridges. With a gas turbine, 5 meter 33 high, placed on steel supports and 4 centimeters freeboard of the barge, we needed a minimum clearance under the bridge of 5 meters 76. From the first barge trip, we knew that we couldn't reach the third bridge at the same low tide, so we took our time and accurately maneuvered the barge underneath both bridges. By pumping, we emptied the ballast tanks and towed the barge to its temporary mooring place near the third bridge. 2 days later, the tide was low enough to navigate the barge with its load underneath the lowest bridges. Completely ballasted down, with only 8 centimeter clearance and a few centimeters freeboard, the convoy slowly moved upstream underneath the remaining 3 bridges. Again, the ballast tanks were pumped empty in order to reduce the draft of the barge. While deballasting, we waited for the tide to come in. Slowly the water level in the inner harbour raised to approximately 2-meter depth. At 4 o'clock that same afternoon, the barge was pushed to the jetty's front. Then an enormous thunderstorm broke loose. Within minutes, the access road to the job site changed into a mud pool. Work was continued the next morning. First, the discharging and transporting of the general cargo, and then the combustion chamber could be rolled off from the barge for offloading at the storage area. In January 1992, the third unit arrived at Port Klang on board of Jumbo's heavy lift ship Stella Nova. Customs and immigration boarded the vessel, and after completion of all formalities, an hour later, the discharge operation started. The heavy lift barge with steel deck supports was towed alongside the vessel, and preparations were made to lift the generator first. This time the ship carried a full load, consisting of a gas turbine, a generator and 2 transformers, which all had to fit on the same barge. Early next morning we started discharging the generator. A 250 tons derrick of the Stella Nova could just lift the 236 tons unit. The generator was turned into the correct position and slowly lowered down onto the steel deck supports. Even with a height of 4.48 meters, we figured out that both transformers could be placed on deck supports as well, provided these supports were not higher than 1.26 meters. With support beams of 30 centimeters high, there only remained 96 centimeter clearance between deck and support beam. This should just be enough to maneuver the trailer underneath. Finally, the heaviest piece, the 320 tons gas turbine, had to be lifted from the hold. As each derrick only had a maximum lifting capacity of 250 tons, we rigged a special lifting beam. In this way we combined both derricks and could easily lift the 320 tons unit. The yellow stabilizer pontoon is clearly visible at the forward side of the vessel and increases ship stability while unloading extreme heavy lifts. Accurately, the gas turbine is positioned on the load spreading beams on deck of the barge. After lashing and securing, we leave early the next morning towards the first bridges. As the heavy lift vessel arrived rather late in Port Klang, we had to hurry in order to meet the low water period in time. The barge was ballasted down as much as possible, and around 10 o'clock on the 1st of February we passed underneath the first 2 bridges. Again, the ballast tanks were emptied while towing the barge from Port Klang to the second set of 3 bridges near Klang town. With its cargo worth more than $30 million, the barge gradually plowed its way through the polluted waters of the Klang River. It took us 2.5 hours to get to the next bridge. In the meantime, the tide was rising again, so we moored the barge along the riverbank and tied her down to some strong trees. The next day, around 9 o'clock, we pulled the barge towards the lowest bridge, while filling up the ballast tanks. We were right in time and waited while the tide was going out. It was the first time we moved underneath the bridges with 4 heavy lifts on the same barge. Especially both transformers with a height above deck of 5.74 m were very close to the ultimate limit. It went all right, and after having passed these obstacles, the way was free to the jetty.
Slowly forward!
From 3 o'clock that afternoon until 5 we had to wait for the rising tide. At the same time we emptied the ballast tanks again in order to get minimum draft of the barge. Some monkeys in nearby trees wondered what was going on. That same evening the barge was safely pulled into the inner harbour with some assistance of both prime movers ashore. We split crews, as we had to load the generator and start jacking the gas turbine at the same time. The double-wide 11-axle Nikola trailer was maneuvered under the generator and loaded her by means of the trailer's hydraulic suspension system. The Kenworth tractor slowly pulled the 330 tons transport combination from the barge. The hydraulic axle compensation system ensures an even load distribution over all tires. Steel ro-ro rams span the gap between barge deck and jetty head. When the axle compensation system had reached its maximum stroke, we stopped and adjusted the level of the front part of the trailer hydraulically. The diffuser was loaded earlier on a normal low loader and was transported to the machine hall and offloaded. Directly thereafter the generator followed. All transports with a height above 5.30 m require the off-switching of the 66 kV high tension lines. This was carefully coordinated with the local electricity board, Tenaga National. Due to heavy rains, the grip on the side roads left much to be desired. So we used both heavy-duty tractors, the tractor mass in front, followed by the Kenworth. Now most of the obstacles en route have been passed and we only had to maneuver the load into the nearby machine hall alongside the foundation. While jacking of the gas turbine still continued, we loaded the first 140 tons transformer that same afternoon. For this work, a 10 axle line Connaught trailer was used. The generator in the meantime had reached its destination and was offloaded. We were at work on 3 locations. One team jacked up the gas turbine, while another crew rolled off and transported the first transformer, and the third team offloaded the generator. Especially the ground conditions near the transformer foundations were very bad. Steel plates were necessary to improve these side roads. Again, heavy rain fell down. Lucky enough, we had prepared a kind of tent so the jacking work could be continued. In the machine hall, the generator was offloaded and skidded sideways above the foundation. Now the second transformer was loaded on the 10 axle line trailer. After lashing, she was rolled off and parked aside so it could be transported together with the gas turbine the next day. The gas turbine had finally reached its required height. The center supports were released and removed so that the double wide trailer could be maneuvered underneath the gas turbine. Again, after loading, the Kenworth pulled the transport combination across the barge deck to the roll-off ramps and rolled off. With the barge fixed to ground, no ballasting was required. Both units, the gas turbine followed by the transformer, were moved in convoy to the foundation. By now the transport team knew exactly what to do, and without a problem we pulled the heavy load straight into the machine hall. As this film demonstrates, Container National and Jumbo can really take a weight off your shoulders. We have the know-how and experience for transportation of heavy lifts from door to door. Our engineering department not only can advise you on shipping problems, but we are there as well to assist you in pre-carriage and on-carriage. If required, our engineers can carry out detailed road surveys and feasibility studies. If there's no obvious solution to a particular transportation problem, call the specialists at Jumbo and we are sure we'll find a solution for you. For ABB we shipped and transported safely a total of 6,600 freight tons of heavy power generation equipment to 3 different job sites in Peninsula Malaysia.